So, good morning to everyone. Yes, today I can see the message. Fine. Good morning. I think according to timetable, chemistry is at 10:20, right? Okay, good morning. Good morning. Good morning. So, okay, fine. So, in that case, before starting with today's concept, as usual, yesterday's one, I will give a brief view. Fine. So, what we have discussed yesterday's class? Fine. Good morning to everyone. So, anyone, what we have discussed in the yesterday's class? So, we have discussed about antimicrobials, right? Many important concepts we have discussed in yesterday's class. Antimicrobials. So, that's where we have discussed about antibiotics. Now, when it comes to antibiotics, broad spectrum, narrow spectrum. Yes, Kirtana. So, it should be antimicrobials. Yes. So, that's where we have the antibiotics. Then we have the antiseptics. Then we have discussed about disinfectants. Right? So when it comes to antibiotics, it can be inhaled. Antiseptics applied on the skin, and disinfectant applied on the non-living surface. Right? So that's where we have discussed about antiseptics, Dettol. So Dettol is an example for antiseptic. Chloroxylenol and terpeneol are the components of the Dettol. You have to remember this. Fine. So then we have discussed about disinfectants, where less than 1%, around 0.2% of phenol is antiseptic. But same thing, if I increase to 1%, now it will act as a disinfectant. Which one? Phenol. Right? So someone has written Jahnavi. Yes, I had only forgotten. We have discussed before this analgesics. Very important. Right? So where we have discussed about narcotic and non-narcotic. In this, remember about aspirin. Fine? So that's where we have discussed antimicrobial, analgesics, then anti-fertility drugs. Yes, anti-fertility drugs, where they will design the molecule which can mimic either progesterone or estrogen. So individual we can consume, or in combination they can act as a anti-fertility drugs. Right? So what else we have discussed? Chemicals in food. Very good. Then we have discussed about chemicals in food. Right? So that's where this was the first concept, this was second, then third, then fourth. Chemicals in food. So when it comes to chemicals in food, we have discussed about preservatives, right? Sodium benzoate, can be the example for preservatives. Hodalva. So gobi manchuri, one of the component will be sodium benzoate. So sometimes they are telling that this chemical can lead to cancerous condition. This condition can lead to cancerous condition. That's where we have the preservatives. I'm not talking about natural sugar and all. I'm talking about chemicals, artificial, synthetic molecules like sodium benzoate and all. They can lead to cancerous condition. Some research they tell. So don't eat mushroom gobi manchuri outside. Fine. So that's where preservatives. Yes, carcinogen. Okay. Then we have discussed about artificial sweeteners. And many times they have asked this one about artificial sweeteners, where we have aspartame, maltame, saccharin, sucralose. They are all example for artificial sweeteners. Then we have discussed at the end, before leaving, I have discussed about saponification. Right? So we have discussed about saponification. So when it comes to these concepts, very often, competitive exam, anything you can expect. But when it comes to board, very often they have asked about components of Dettol. Then they have asked definition for analgesics. Then they have asked about sweeteners. Fine. So now, another important one is saponification. So these are the some of the points. Now when it comes to saponification, yes, Bharat, where triglyceride will be treated with alkali like sodium hydroxide or potassium hydroxide, which will get converted into soaps. Right? That is nothing but salts of fatty acid, which will get converted into soap. That's where we have the saponification process. Fine? So, any doubts in all those things? Anything? You have the doubts? Or I can continue for today's concept, because after this, once I finish the chemistry in everyday life, we are going to discuss another small chapter related to organic chemistry only, that is polymers. We will finish off the polymers also in this week. Okay? Now, in that case, next concept here is, that's what I was talking about, detergents. Soaps, all of you have understood what you mean by soaps. And in surface chemistry, okay, what is BTH and BTA? Where you found these words? Sanjana? You know, I am not getting. What is BTH, BTA? Short form. Anywhere it is there in the textbook? I am not seen. BTH, BTA, BHT, BHT, butyl hydroxytoluene. That chemical is there, but I don't know where you have found. Okay, it's an antioxidant. BHA and BHT. Antioxidant. Okay, I will just see. And I will let you know. Okay, Sanjay. Fine, it's there in the textbook. Okay, fine. I will just see what is that chemical and I will let you know. Okay, so no need to worry. Butylated hydroxy, that's what I was telling. Butylated hydroxytoluene.
Anisole.
That is anisole, yes. Butylated hydroxy anisole. So I think that one you are going to discuss in alcohol topic also. Butylated hydroxy anisole. It comes under ether also, because anisole is a ether compound. Fine. Anyway, I will tell you. So with regard to antioxidant, how they are functioning, you wanted to know. That one I will tell you. Okay. That's what butylated hydroxy anisole and butylated hydroxytoluene. Anisole is comes under with respect to ether topic. Okay. So anyway, I will let you know how they are going to function as a antioxidant. Fine. Definitely I will clear it tomorrow. So in that case, we'll move to the detergents. Now when I am talking about detergents, so these are the chemicals which will have the similar action as that of the soaps, that is related to cleansing action. Cleansing action already we have discussed with respect to your surface chemistry topic, right? So now we will come to next one, that is with respect to detergent. What is actually detergents? What is that difference between soaps and detergents? And in brief already I have discussed in surface chemistry, because when it comes to soaps, the problem with soaps is it will not work in all the water. Hard water is not going to work. So that's what I told, it will form scum, right? So that's where we have the chemical, that is soap. Fine. So in that case, when it comes to detergents, which we have discussed, we are going to discuss that one as synthetic. Because when I am talking about soap, salt of fatty acid. Fatty acid is a natural chemical. It's not synthetic one. So when it comes to detergent, most of them, they are synthetic one. In that, very often you can expect the question on anionic detergent. Preparation of anionic detergent, or with respect to example for anionic detergent. So before giving anionic, in the name itself it is that it should be having negative charge. It should be having the negative charge. Fine. So when I am talking about anionic detergent, okay, I am remembering BHT and BHA. One of the function or antioxidant, don't get this one, I was thinking that only in my mind. So when I am talking about BHA and BHT and all, these are the antioxidants, or I can tell antioxidants can function in different ways. In one case they can act as H plus donors, or they can act as electron donors. Fine. So in all the cases they will act as an antioxidant, because when I am talking about reactive oxygen species, if I take superoxide anion, so this is a radical. Superoxide anion is a radical. This dot indicates it is a radical. So therefore, these are the antioxidants are the chemical. When they will donate H plus, electron will be shared. Or when they donate the electron, lone electron will become lone pair of electrons. So that's how these antioxidants they are going to function. Please remember, most of the reactive oxygen species, ROS, all of them are having lone electron. That means all of them, they are radicals. Okay. So now, therefore, these chemicals which will act as an antioxidant, they will provide either electron or H plus. Fine. So that's how they are going to neutralize the lone electron, and they will convert them into lone pair of electron, or they will make them to involve in the bond formation. That's how most of the antioxidants they are going to function. Fine. All of you have understood? So that's where we have the BHT and BHA. But anyway, if you want in detail, I will explain it. This was a brief view about how these antioxidants they are going to function. Now when it comes to antioxidant, we have lots and lots of antioxidant. Like yesterday I was telling, in green tea we have catechin, epicatechin, right? So which is there in your textbook, catechol. Everything comes when you are talking about alcohol topic. So most of the phenols, what are phenols? These are the organic compound containing benzene ring with OH group. They are called as phenols. In that we have the polyphenols. So most of the polyphenols, they will act as a antioxidants. Fine. So anyway, I will let you know in detail in tomorrow's class, but this was a brief view. Fine. So I will come back to this topic. So I was talking about anionic detergents, right? So when I am talking about anionic detergents, they are negatively charged. See, for example, I have one particular alcohol, CH3, CH2, 10 times CH2OH. So this is the alcohol, right? So how many carbons are there in this molecule? It is 10, 11, 12. So it is a 12 carbon containing alcohol, right? So I can write it as dodecyl alcohol or dodecanol. Anything is fine. Dodecyl alcohol or dodecanol. Dodeca means 12, right? Same way. It can also be commonly called as lauryl alcohol. It can also be called as lauryl alcohol. Lauric acid, laurate. It is a 12 carbon containing fatty acid present in our coconut oil. Same way, we have the lauryl alcohol where instead of carboxylic group, it is having OH. Fine. So when this lauryl alcohol is treated with one of the chemical, anyone, can you tell me which is this chemical? Anyone? This is lauryl alcohol. What is this? Any one of you? It is a sulfuric acid. Sir, idana seedha bariboodalva? Okay, fine. I will write like this. That's where I have the sulfuric acid. Why I have written this structure? Because you can expect in your exam, P block 11, 1 mark question. Nitya, correct. It is sulfuric acid. Now there will be liberation of water, H plus from sulfuric acid and this OH minus from the alcohol. Fine. So that's where bond will be getting cleaved. Right. Now what will happen? Now due to the liberation of water, OH minus, then it will become CH2 plus. Right. So to make you understand, I am writing separately CH2, 10, then CH2, that is plus, and another one will be O minus OH, that is HSO4 minus, bisulfate. HSO4 minus means bisulfate. This is nothing but bisulfate ion. Right? Now, due to negative and positive, they will interact with each other. So therefore, I am going to get CH2O, S double bond O, OH. Lauryl sulfate or lauryl sulfuric acid. Sulfate means I have not written ionic form, therefore. Okay, na? So this is not required actually. Directly you should write this one. To make you understand, I have written. So therefore, I will remove this. Fine. So therefore, this is the product. This is what we are going to get. Now, when I will expose this chemical to sodium hydroxide, naturally it is a base, strong base, OH minus, H plus. Once again, neutralization reaction. There will be liberation of water. Now what is there which is left over? CH2, 10 times CH2O, double bond O, O minus and Na plus. Got my point? So this is where we have the final product. This is what we have the final product. It can also be written as, I will write as it is given in your textbook. CH2 O SO3 Na plus. Anything is fine. This is also fine. This is also fine. Right? So this molecule can be called as sodium lauryl sulfate. This molecule can be called as sodium lauryl sulfate. Okay, or anything is fine. Lauryl sulfate sodium, or normally they will call it as sodium lauryl sulfate. Another very common name for this one is sodium dodecyl sulfate. One and all same. Sodium lauryl sulfate or sodium dodecyl sulfate. One and all same. I will come to that. Now, when I am talking about this one, short form is SDS. When I am talking about sodium dodecyl sulfate, SDS, it is a very good example for anionic detergent. Now, Kirtana, lauryl. So that lauryl name came because it was first found as a lauric acid. I was telling it is one of the component in coconut oil, which is a lauric acid, 12 carbon containing molecule. So 12 carbon containing hydrocarbon will be called as lauryl. Okay, so therefore they have given the name it as lauryl alcohol. If this is carboxyl group, then it will be called as lauric acid. So lauryl stands for 12 carbon. Laur is A, from where it has been isolated. Okay, first, therefore based on that they have given the name. Fine. Now we have understood. Because of that they have given some of the common name. Otherwise, if you go with IUPAC type, lauryl cannot be acceptable. It can be called as dodeca. Dodeca means 12 carbon. Fine. So that's where we have the SDS, one of the common example for anionic detergent. Because when you put it into water, when you put it into water naturally, Na plus will get dissociated. In that case, what is the charge left over? It will be having negative charge. It will have the negative charge. Therefore, it is a anionic detergent. And this is how anionic detergent will be prepared. Fine. So now, why it is called as a detergent? Because it is having long hydrocarbon chain, which is non-polar. Then it is having sulfate group, which is polar, which is charged. So therefore it is a very good property of a detergent, as I have discussed in the surface chemistry. Right? So this type of molecules will be called as, there is one specific name, a molecule containing non-polar part and polar part. I have discussed this one in surface chemistry. What is that? Name of the molecule. That should be the property of soaps and detergents. In soaps also, fatty acid, long hydrocarbon chain. Yes, it will be not apathic, it is amphipathic. Okay, na? So those type of molecules are called as amphipathic. Okay, so which is having both polar and non-polar. That's fine, that's fine. So that's where we have the amphipathic. Fine. Jahnavi, hydrophilic means only polar part will be there. But here we are talking about hydrophobic also, hydrophilic also. So those type of molecule will be called as amphipathic molecule. So this is one of the important point, that is with respect to anionic detergent. Even preparation we have discussed. All of you have understood? So this is with regard to anionic detergent. Same way, we have cationic detergents. Preparation is not there, no need to worry. We have cationic detergents. Fine. Now, why they are called as anionic detergents? What is the reason why they should be called as anionic detergents? Anyone? What might be the reason why it should be called as anionic detergent? That is because in the water they will get dissociated as negatively charged molecule, right? So yes, they will be formed anions. So therefore that one was called as anionic detergent. Example is SDS or sodium lauryl sulfate. Anything is fine. But here we are talking about cationic detergent. That means there should be presence of cations. Yes, Purnima, that is due to negative charge. But here, when I am talking about cationic detergent, it should have the positive charge. So one of the example for this one is cetyl trimethyl ammonium bromide. Cetyl trimethyl ammonium bromide. Now, lauryl, it was 12 carbon. Cetyl, it is for 16 carbon. So, cetyl stands for 16 carbon. Fine. So, that's where cetyl trimethyl ammonium bromide. Yes, Ravikant. CTAB. Short form like SDS, here it will be CTAB. To make you understand, I can write 16 carbon, right? CH3, CH2, 14 times CH2. How many carbon? 14, 15, 16. So cetyl, that is done. That is 16 carbon is done. Then ammonium, right? So where nitrogen will be attached with the 3-methyl group because it is written as trimethyl, right? So that's where I have written methyl group, 3-methyl group. Now, here nitrogen will have the positive charge. Why nitrogen will have the positive charge? Due to the presence of tetravalence. So due to the presence of tetravalent character, nitrogen is having positive charge. Now, it will be in combination with Br minus. It will be in combination with Br minus. So therefore, when we add it to the water, it will become CH3, CH2, 14 times CH2 and CH3, CH3, CH3 and positive charge. Right? So there is a formation of cation. So due to that, it is an example for cationic detergent. So anionic detergent, cationic detergent. All of you have understood? So that's where we have the cetyl trimethyl ammonium bromide. CTAB is a very good example for cationic detergents. Fine? All of you have understood? So when it comes to cationic detergents, no need to worry. They will not ask about structure and all. To make you understand, I have written the structure. But with respect to anionic detergent, 1 mark question they have asked. That is related to anionic detergents. SDS. Fine. Now we will come to next one. That is non-ionic. Sir, it is used in hair conditioners. Fine. Yes. It can be used. Even SDS, to some extent they will use. And even SDS is having lots and lots of application with respect to research. Right? So it is having lots and lots of application. But when it comes to SDS and all, they will act as a strong detergents. So too strong detergents also it can spoil the condition. So therefore, a mild amount it will be used. Yes, you are right, Ravika. Fine. So along with that, for hair conditioners, we have many other chemicals which will be used. Even glycerol will be used. Now next one is non-ionic detergents. Next one is non-ionic detergents. Now, when I am talking about non-ionic detergents, in the name itself it is that it does not have any charge. No positive charge, no negative charge. Therefore, they are called as non-ionic detergents. Fine. So, in that case, one of the example here is, when it comes to non-ionic detergent, one of the example here is, yes, neutral charge. Neutral charge in the sense, there is no charge. There is no positive, there is no negative, not even equal amount also. Fine. So that's where they will be called as non-ionic. So when I am talking about neutral, it tells that it can indicate that there is a positive and a negative charge which are in equal amount, then it will be called as neutral. But here there is no charge at all, no positive, no negative charge. So therefore they are non-ionic detergent. Now we have stearic acid. We have stearic acid. Now when I am talking about stearic acid, it's a fatty acid. 16 carbon containing fatty acid. That is where we have the stearic acid. Fine. Now when I am talking about this chemical CH3, CH2, COOH. So that means 14, 15, 16. Right? That's where we have the 14, 15, 16. Fine. So hagadre, when I am talking about this particular fatty acid, when it is treated with polyethylene glycol, when it is treated with polyethylene, I think it should be there. When it is treated with polyethylene glycol. Now naturally, polyethylene glycol means we have ethylene group. Okay. This is, I think stearic acid should be 18 carbon, if I am right. It should be 18 carbon. Lauric, myristic, palmitic acid, stearic acid. Yes, stearic acid is a 18 carbon fatty acid. 16, 17, 18. Yes, that's why we have the stearic acid. So when it is treated with polyethylene glycol, ethylene glycol means OH, OH. That is nothing but ethylene glycol. Now I am telling polyethylene glycol. That means this structure will be repeated n number of times. So therefore, when I am talking about polyethylene glycol, it will be CH2, CH2, O, n number of times, CH2, CH2, OH. So that's where PEG, PEG. PEG means not that PEG. Okay. So it is a short form, polyethylene glycol. So polyethylene glycol. Okay, now once again there will be liberation of water. So H plus and OH minus. So that's where we are going to have the detergent, non-ionic detergent. CH3, CH2 16 times, COO, CH2, CH2, n number of times, CH2, CH2, OH. So this is where we have stearoyl polyethylene glycol. The product is stearoyl polyethylene glycol, which is a non-ionic detergent. So how we have got this non-ionic detergent? We have got this one by the help of stearic acid and polyethylene glycol. Fine? All of you have understood? Okay. So that's where I think Amit has done polypropylene glycol stearate. But propyl group, it's not there, no? It's 2,2 carbon. So polyethylene glycol stearate or stearoyl polyethylene glycol. Anything is fine. Fine? All of you have understood? Stearoyl polyethylene glycol. That is fine. So that's where we have the non-ionic detergent. Any charge is there? No charge. Right? But it is having ester ring. On one side we have polar part, that is OH group. Then we have the non-polar part, long hydrocarbon chain. All of you have understood? Fine. So that's where we have the anionic, cationic and non-ionic detergents, which is now replacing whatever earlier they used to use the soaps. All these detergents, they are replacing whatever earlier we used to use the regular soap. And the problem with that regular soap was, it was not working well with all the quality of water. Therefore, it is getting replaced. Even nowadays, we have some of the detergent powder, right? Whatever powder we are getting, Rin, Ariel, right? So, which will be like granules. So those granules are also nothing but these detergents only. But along with those chemicals, they'll be adding some of the enzymes. Enzymes can be protease. They'll be adding these type of enzymes so that to enhance the cleansing action. To enhance the cleansing action. So these enzymes, what they will do? Whatever stains are there on the cloths, even they will hydrolyze those molecules. Right? So that's why cost of those detergents will be more due to the addition of enzymes to those beads. All of you have understood? So that's where we have the synthetic detergents. Now only disadvantage about this detergent here is they are not easily biodegradable. They are not easily biodegradable because when I am talking about the nature, we have our very well friend microorganisms which will be helpful in destroying or not destroying, which will be helpful in catabolizing some of the chemicals by which it will reduce the pollution level. But whatever detergents we are using, they cannot be easily degradable. Right? That's what I have written, not easily biodegradable. So they will remain in the environment for a long time. But please remember, any chemical which lives in the environment for a long time, they are toxic molecule, toxic to environment. They can be considered as a pollutants. Whether I am clear? So therefore, detergents are the one of the pollutant which is involved in formation of the froth in the river or ponds. We can see in Bangalore and all, some of the Kengeri, near to that Kengeri one, water this one is there, right? Always it will be having lots and lots of froth. So one of the reason might be due to detergents, which is added to those waters through sewage. Fine. So that is the one of the major disadvantage with respect to these detergents. Fine. All of you have understood? And with respect to BH and BHD, definitely I will come back to you. And that's how they are going to function, no doubt. But if you want in detail, I will come back to you tomorrow. Okay? Other than that, any other doubts are there? If you don't have any doubt, then we have finished with this chapter. We have finished with chemistry in everyday life. We are moving to the next chapter, that is polymers. So before going to polymers, if you have any doubts, you can ask. Okay. So in that case, shall I move to the next one? That is polymers. Hagadre, when I am talking about polymers, it's a bit important topic compared to chemistry in everyday life. Because for your board exam, you can expect 4 to 5 marks from the polymer topic. 4 to 5 marks for the polymer topic. Sir, does polymers also have long names to memorize? Okay, yes, it is there. Okay, and many are there, not one, many are there in polymers. Fine. Same way for 4 to 5 marks, that is for board exam. When it comes to competitive exam, you can expect 1 to 2 question definitely. That is 2 question means is very pretty good question only with respect to NEET exam and all. So 1 to 2 question it will be there. Fine. With regard to polymers. Now I will start with the introduction. When I am talking about the polymers, in the name itself it is there. Already we have discussed the polysaccharide, right? Then polypeptide. So that's where already we have done with the poly. Poly means many. Mers means monomers. Mers means monomers. So that's where, as we have discussed with regard to polysaccharide, which can be an example for polymer, as we have discussed polypeptide, which can be an example for polymers, but they are all naturally present. Right? They are all naturally present. Yes, Aishwarya. Polymers can be called as macromolecules, no doubt. So polypeptide, even protein, even starch, glycogen, they are all polymers only, where they are having many number of monomeric units, mers, right? So therefore we can call them as a polymers. But only thing here is, whatever names I have taken now, they are all naturally present. So they are all example for natural polymers. But if you see surrounding us, whatever tie I am wearing, whatever shirt I am wearing, right? So all these things, they are nothing but polymers only. Different types of polymers. When we are riding the vehicle, that tire, that tube, everything is a polymer, right? So that's where we can see the polymers, synthetic polymers. I am talking about synthetic polymers surrounding us, because in day-to-day life, without these synthetic polymers, we cannot imagine our life itself. Right? When you woke up, you are going to do your brushing, right? So that toothbrush, whatever is there, that is also polymer. When you are combing, not applicable for me. Whenever we are combing, that comb is a polymer. When you are taking bath, that bucket, mug, whatever it is there, everything is a polymer. We are wearing the clothes, it is a polymer. We are watching TV, that TV, whatever cover is, everything, it is a polymer. Right? If you see that TV stand, if it is made up of wood, that is polymer. If it is plastic, that is polymer. Everywhere we have the polymers. We cannot imagine our life as that of our cell. Even our life is not imaginable without polymers. Almost all plastic items, yes, they are all polymers. In that only different changes are there because it is man-made. We have done some changes, right? So yes, I mean, all the plastics, they are nothing but polymers. But only thing here is natural polymers are easily degradable, because it is naturally present. Whenever nature is designing something, it will design in such a way that whatever it has created, it should have the lifespan, it should be degraded faster. But we the human beings, whatever we have prepared, will make sure that it should be there for a long time. That's where we are spoiling the nature, right? So that's what polymers means. These are the macromolecules which are made up of n number of monomers, which are made up of n number of monomers. That's where we have the polymer definition. So what are polymers? These are the macromolecules which are having n number of monomers, or which are made up of n number of monomers, or which on hydrolysis can give n number of monomers. Same as that of polysaccharide, you can apply the definition here also. Fine, Ravikant, that's where we have the polymers. Now we have the process called as polymerization. Polymer, we are dealing with the molecule. But when I am telling about polymerization, we are talking about the process. So polymerization is a process where there will be synthesis of polymers using n number of monomers. What is polymerization? Polymerization is a process where n number of monomers will be used to form the polymers. Fine. So long chain molecule of high molecular weight by large number of simple molecule. Fine. That is also fine. Manu. Absolutely correct. Right? So that's where we have the polymers, and that's where we have the polymerization. Okay? All of you have understood? Amit, correct. Monomers are the structural unit of the polymers. All of you have understood this one? Okay? So in that case, what we will do is, now we will move to the classification. Classification of polymers. So whenever I am giving example, don't worry, in detail those example we are going to discuss whenever it is required. For time being, you just remember the name, whatever I will tell. So classification of polymers. So one is based on the classification based on the occurrence. Okay, na? So based on the occurrence, whether they are naturally present or they are synthetic one. So based on the occurrence. Okay. So in that case, first one will be natural polymers. First one will be natural polymers. So naturally, natural polymers example can be, it will be starch, glycogen, anything. It can be starch, glycogen, even one of the abundant polymer is cellulose, right? So that's where they are the natural polymers. Yes, it can be one source also, I mean, correct. So based on the occurrence or source, anything is fine. So that's where we have the natural polymer. Example can be cellulose, starch, glycogen. They are all naturally present in the nature. Even resins, yes. Many resins are there. Rosin, one of the resin, rosin, which is used for the soaps. Especially shaving creams and all, they will use one of the resin, which is called as rosin, which is isolated from the trees, conifer plants. Even rubber, naturally occurring rubber can be the example here. Natural rubber. But we have modified the rubber also, which we are going to discuss. But here, yes, natural rubber. We should mention it as natural rubber. Yes, we can include that one here. Natural rubber. Okay? Because we have vulcanized rubber. Vulcanized rubber is not natural one, which we have changed. That whatever natural rubber is there, we have made it some changes. So that one can be included in semi-synthetic rubber, semi-synthetic polymer. That's what. Next one is semi-synthetic polymer. Next one will be semi-synthetic polymer. Now in the name itself it is there, semi-synthetic. Semi means partial, not completely synthesized or completely natural one. It is slightly modified. That's where they are called as semi-synthetic polymers. Now when I am talking about semi-synthetic polymer, we have discussed about one process called as dialysis. All of you remember? So in that I have told they will use dialysis membrane. Dialyzing membrane they will use, right? And I told one chemical which is called as nitrocellulose, if you recollect, right? So that's where nitrocellulose can be the best example. Nitrocellulose can be the best example for synthetic polymer, semi-synthetic polymer. In the same way, vulcanized rubber can be an example for semi-synthetic polymer. Anything is fine. Okay? And the last one is synthetic, and here we can have n number of examples. Synthetic polymers. But try to avoid writing plastic and all. Mention the name. Mention the name of that polymer. Plastic is a general name. Okay? So synthetic polymers, it can be PVC. Whatever pipes we can see, that is polyvinyl chloride. PVC is nothing but polyvinyl chloride, right? Same way, someone had written nylon. Yes, nylon 66 and all, they can be the example. Nylon 66. Okay? So even we can write any other example. Don't write polyisoprene. Polyisoprene will come under natural rubber. Rayon, yes, it can be done. Rayon can be included. Fine. These are some of the examples. Teflon, yes. So that's where we have some of the example for synthetic polymers. Even Teflon can be included here, no doubt. Okay. So any other doubts? So that's where it is based on the occurrence or based on the source. We can classify polymers into natural, semi-synthetic and synthetic polymers. All of you have understood? So next one is based on the intermolecular force. Or before that, I think you have the structure, I think so. So based on the structure, fine, we will go with the textbook one. Based on the structure. Yes, Buna N, Buna means Buna S or Buna N, anything can be the example. Okay? So based on the structure, classification based on the structure. First one will be linear polymer. First one will be linear polymer. So PVC can be the best example for linear polymer. Right? So PVC can be the best example for linear polymer. Even natural rubber. Even natural rubber can be the example for linear polymer. Even cellulose, natural rubber jotege, even include cellulose. Even Teflon can be the example for linear polymer. So there are many. So in the name itself it is that there is no branch, it's a linear structure. Right? So next one. Okay, represented as fine. So that's where we have the linear polymer. So next one is branched polymer. Next one will be branched polymer. Now when it comes to branched polymer, so we have, I think in your syllabus, I think we have only few examples. I'm not talking about glycogen and starch. So we can include low density rubber. We can include low density rubber, which is a semi-synthetic one only, but it is a branched polymer. Low density rubber can be the example for branched polymer. Okay? So same way, yes, even low density polythene can be included. Low density polythene can be included. Yes. I think low density polythene only is there in your textbook. Right? So fine. So in that case we will remove this to avoid the confusion. I think low density, yes, low density polythene, branched polymer. If you come with the natural one, it can be glycogen or it can be cellulose. They are all example for branched polymer, branched natural polymers. Right? So low density polythene, yes, it is there in your syllabus. So next one, cross-linked. Example, cross-linked. Ravikant, example low density means. So that question I am not understanding. Example low density. So that's what? Low density polythene. Example. Low density in the sense where we have high density polythene also, which will be prepared under different conditions. Conditions will be different. So high density polythene will be prepared in the presence of one catalyst, which we are going to discuss. Okay? So under that condition there will be high amount of polythene will be there, but they will not be branched, they will be linear. But low density means where less amount of polythene will be there and even reaction conditions will be different. So during that time there will be formation of branches. Fine? So that's where we have the branched polymer. Now last one here is, that is nothing but linear branched cross-linked. And here one of the best example is bakelite, important one. You can expect the question. That is bakelite can be the best example for cross-linked polymer. Okay? So cross-linked, that means when I am talking about branches, so this is where we have the branch, right? But when it comes to cross-linked, so that's where one polymer will have the linkage with the another polymer. That's where we have the bakelite. Bakelite is the polymer which will be produced further from the novolac. So that one anyway, we are going to discuss that one in detail, I mean. So no need to worry. So that's where we have the bakelite is the one of the best example. Yes, even melamine can be the best example for cross-linked polymers. They are all resulted due to condensation polymerization. Fine. So anyway, we will be using that. Everything with application also we have to discuss. No need to further. But for time being, remember the example for linear, branch and cross-link. Especially for cross-link, you remember. That is bakelite. Very often they have asked. Even you can include melamine also, which is there in textbook also, in your syllabus. Fine. So anyway, I will stop here. These are the classification based on the structure. These are the classification based on the structure. Fine. So you knew the answer. Okay, I am not getting. Okay. So in that case, what we have discussed in polymer topic is that is related to polymer topic, that is related to definition of polymers. Then we have discussed about polymerization, what you mean by polymerization. Then we have discussed about classification with respect to occurrence and then with respect to structure. So next classification, which is a bit important. So this one, that one we are going to discuss in the tomorrow's class. Any doubts? Okay. So if you don't have any doubts, fine. Then we will discuss in the tomorrow's class. Okay. And you want me to discuss in detail about BHT and BHA? Anyone? Someone had asked the question, right? BHT and BHA. Okay. Anyway, tomorrow you can tell me whether you want in detail. I'm ready to discuss that. Fine. So we will continue in the next class. Thank you. Take care. Okay.